So whatever we are learning with respect to quadratic equations or the things that is coming our way, these are the building blocks. This is the time for us to strengthen our concepts and be ready for exams which will be a little more, I would not say tough, but there will be a little bit more complexity involved. So if our base is strong, it will be easy for us to relate and kind of deal with them. So I would request Myra and Smarni also to turn on their videos if it's okay. I mean if you are comfortable, so that your friends don't feel different. Everybody stays on video. Okay, yeah. All right.
So I'm outside, so like I have to put my video off, and it's gonna be.
No, okay, that's fine. That's why I said if it's okay. Okay, so I'm not trying to bother you guys for turning your videos on, but if you keep it on, that makes it better. Okay, so let me just send a reminder to the kids that class has started. All right. So whatever we are learning here is part of quadratic equations or different concepts. These are your building blocks for your future exams, when things will get a little more competitive, little more intense, concept-wise, not stress-wise. Okay. So the thing that we learned so far with respect to quadratic equations, I will not go too deep into it because we'll do that any which way once we go to level 3. Okay, Arihan. So we're just going to cover the basic concepts, the very high level view, so that we are clear about what exactly those are. Okay. So Nihan, do you want to explain what is a quadratic equation? Let's see how much you guys retain. Conceptually, at a very high level, what is a quadratic equation?
Quadratic what?
What is a quadratic equation? What we have been covering in last couple of classes. Not prepared? Okay, how about you, Arihan? See again, there's one more thing that I wanted to emphasize here in the class. That when you learn something and if you are able to explain that to somebody, that means you have learned it enough to be able to teach. So just learning is not enough. If you are able to explain that to somebody, that completes the circle for you. Arihan, do you want to give it a shot? Do you want to tell what you know about quadratic equation at a high level?
Like basically, it's like an equation that you have. It has like a variable that maximum power is 2, and then you solve it, and then you put it on like a coordinate plane, and then it forms a parabola.
Yeah. So, yeah. Arav, you want to give it a shot? In 2 lines.
I think the CP says we can also graph it into a graph. Yeah, kind of what he said.
Okay. Myra, any thoughts around it?
I don't think I know this one that well.
Okay, how about you, Smarni?
Huh?
Do you want to describe what is a quadratic equation? What is your very high level view of quadratic equation?
It's usually, so like on the graph it would be a parabola.
Okay. How about you, Dikshita?
It's like the equation is like perfect to 2, and it's on the graph it's going to like make a parabola.
Okay. So, fine. Let's go step by step. Everybody is clear about something like this. It's a linear equation. Everybody knows, right? Aditya. Okay. So what do we call as a linear equation is an equation where I have couple of variables, let's say 2 variables in the simplest form, and the maximum power to the variable is 1. Maximum power to the variable is 1. Hello, Samita. So here y is one variable, x is another variable, and both have maximum power as 1. Why I'm insisting on the point, I am emphasizing on the point saying maximum power 1, because I can also write 9 as 9 into x to the power 0, or 9 as 9 into y to the power 0. Correct? Sandy and Suleen? Okay, beta? Okay. So here, what I'm saying is, in an equation, when I have one or more variables, when the maximum power to the variable, here x and y are two variables, the maximum power to them is 1. That is called a linear equation. Why? Because if I look at, again I'll repeat something that Sanvita will not like, but bear with me, beta. So when I said Sanvita, I just gave an example, okay? Dikshita also might not like. But when you have an equation, what is the basic point and the most important compelling point about it is it's nothing but a contract. It's an agreement between the variables. Here y and x have agreed saying that 2 times your value plus 9 will be equal to my value. That's what y says. Okay? X says out of holier horses. Okay, see, horses were not tamed. I had to tame them. Alright, so again, you will have to talk only when I let you guys talk, or when you have a question. I will ask you guys, okay, do you have a question? That is when you have to answer. You don't have to repeat one sentence of mine and interrupt me after every sentence, okay? That's a thumb rule that you have to follow, otherwise we'll be wasting a lot of time. Now, when we say an equation simply means it's an agreement between the variables. X and y have agreed. In this equation, x said, okay, fine, 2 times of my value plus 9 will be your value. Or y said, okay, 2 times of x's value plus 9 will be my value. That's a deal between them. If I look at another equation, 2y minus 7 equal to x by 2, this is a new contract between x and y. Okay? Since I don't see all the faces, I'm still wondering, is it only Dikshita, Sandrine and Suleen who are concerned, or everybody else? Nobody is concerned? Can you guys keep your videos on, please? Except Smarni. Smarni told me why, so it's okay. So here, any equation that you see, it's nothing but a contract or agreement between them. So let's decode that. Let's look at this equation. I'm saying that. Yes, Sanvita.
My video isn't working very well today.
Okay, no problem. Okay. So here, when you look at this equation, y equal to 2x plus 9, I am saying that this is a contract between x and y. Where did Sandy and Swing go? Okay, they are here. Okay, just that they are on the screen. Okay, fine. So here, this is an agreement between x and y. And it says that x and y will change such that this will happen. Or let me rewrite this equation. It becomes y minus 2x equal to 9. Now this is a better looking equation. Same equation. It says that value of y minus 2 times the value of x will be equal to 9. If you increase y, x will decrease or change. If you change x, y will change. So that the total value comes as 9. Okay? That is the agreement. Is that part clear to everybody? So, be it any equation, be it a linear equation or any form of the equation, in simplest form, it's an agreement between the variables. And that agreement will be visible on the table now. Let's look at it. For the linear equation, when I say x equal to 0, what will be the value of y for x equal to 0? This becomes 0, y will be equal to 9. If x becomes 1, what will be the value of y? This becomes 2 plus 9. X becomes, y becomes 11. When I put x equal to 3, 2, y becomes 2 times 2, 4 plus 9, 13. I'm just stopping here. So, see, this was the agreement between x and y. So, for every value of x, there is a corresponding value of y so that this condition is met. Nothing new, right? Sanvita, Myra, Swarni, Sandrine, Suleen, everybody?
Yes, sir.
Everybody clear? Okay. Now, this is a linear equation because all the values that we got, if you plot that in a coordinate plane, you will see that it forms a straight line. Okay? Now, I am talking about another equation y equal to x square. What changed here? The maximum power to the variable is 2. Can I call it a linear equation by any chance? No? Sandra and Suren, what is your point of view?
No.
No. What do you think, Moira?
I think I get it.
I'm sorry?
I think I understand it a bit better now.
No, I'm just asking a question. There's no question about you guys understanding or not. My point is that I had an equation like this, y equal to 2x plus 9, and I shamelessly said that this is a contract between x and y. Now, I'm saying I call this a linear equation because maximum power to the variable was 1. When I found out x and y values and I plotted it, it gave me a straight line. That's why I'm saying, okay, fine. Now I have all the reasons for calling this guy a linear equation. Now, I changed my mind. Instead of looking at this kind of equation, I said y equal to x squared. So my question to you, Myra, is, can I dare to call this guy also a linear equation?
I think so. Yeah.
No, I should not dare. I should not dare. So that's where the concept lies. So that was a question for Myra because I think she was not in the class yesterday. That's why I was asking her.
My dad was an accident.
Okay. Sandin and Sulin, a question to you. Do you think I can dare to call this guy a linear equation by any means? Y equal to x squared. Can I dare to call this guy also a linear equation? That's a question.
No.
No. Because my first or the most fundamental concept here is if my maximum power to the variable is 1, then only I will call it a linear equation. What is my maximum power to, what are the variables? Y and x. What is the maximum power to y? It's 1. What is the maximum power to x? It is 2. Oh, this is a strict no-no if I want to call it a linear equation. Okay? So this guy is not a linear equation by any means. Because as soon as the power of any of the variable goes beyond 1, that is not a linear equation. Yeah? Now you are forced to believe, and I know you guys will start feeling sleepy soon, that oh, this old man is telling me same thing again and again. And I love doing that because I wanted to prove that also. So this equation, I am forcing you guys to believe that this is not a linear equation. Right, Sanvita? And you will say why? Because be it a linear equation or any fancy equation, it's an equation because there is an equal to sign. So, and when I have an equation, that is nothing but agreement between x and y. Yeah? Any equation, it's an agreement between x and y or whatever variable I have. If I am talking about x cubed plus 2y squared minus 9z squared plus l squared plus m squared minus 27 equal to 49. There are so many parties involved. We can literally run election with this many participants. Yeah? So we have x as one participant, y is another participant or variable, z is another one, l is another one, m is another one. So there are so many candidates, but still the basic principle that this is a contract or agreement between these many variables. Too many cooks spoil the food. That will be the recipe coming out of this. But I'm saying it is still underlying. I mean, it is still relating to the one-liner statement that I made. That if I have any equation, that is nothing but an agreement between all the variables. Yeah. I wish, I hope, I will pray that you know how to deal with this equation at least till you come out of high school. But nobody can say this is a wrong equation. Okay, this is still a right equation. Okay, all right. Let's move on. So, coming back to the same fundamental statement one more time. This is an equation, and this is an agreement between y and x. And when I said that I should not dare to call this a linear equation, linear equation is nothing but made of two things, line plus something. So if my equation draws a line, then only I will call a linear equation. So that's what we saw, that something like this, when I have maximum power as 1, it actually draws a straight line for us. Okay. Try doing it as many times you want to prove me wrong. Okay. But prove me wrong or prove the math concept wrong. But any linear equation you deal with, you'll end up drawing a line only, straight line. Okay. Now here this guy will not draw a line for us, and that is what we want to check. So now let's deal with this guy. Y equal to x squared. Same thing, it's an equation, right? So there is a dependency relationship agreement between x and y. Let's look at x and y values. Let's see how does y change for every value of x. When x equal to 0, y is 0. When x equal to 1, y is 1. When x equal to 2, y equals 4. Now interestingly, if I put x equal to minus 1, then also I get y equal to 1. When I put x equal to minus 2, then also I get 4. When I put x equal to 3, I get 9. I put x equal to minus 3, then also I get a 9. Are you guys with me so far? With this table? I just picked some values, okay? Just because I have square here, that's why I just played with the negative and positive both the numbers. Okay? Yeah? So, now let's see. Let's see, Mada was saying that I can still dare to call this guy linear equation. And I was saying that no. Let's see if that is the case. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Here 2, 4, 6, 8, 10. Minus 2, minus 4, minus 6, minus 8. Okay. Now let's see what happens. When I look at first one, Aditya, you have been very quiet, but are you able to follow me better so far?
Yeah.
Okay. Okay. No, so if I go fast or if I start blabbering, stop me, say, sir, I did not understand this. It's perfectly fine, okay? I'm not teaching myself, I'm teaching you guys. If anybody in the class has any doubt, don't hesitate for a genuine reason. I have to put the disclaimer or the caveat saying for a genuine reason, because I know we get tempted to talk even when there is no reason. Alright, coming back to this one. 0, 0. This is my first point. Okay. 1, 1. When x is 1, y is 1. This is probably my second point. When x is 2, y is 4. When x is 2, y is 4. When x is 3, y is 9. See, where did it go? Now, when x is minus 1, y is 1. Hold it, Advik.
You plotted 2, 9 instead of 3, 9.
Okay, you got a good eyesight. Okay. Even if you got glasses like me, you got a better eyesight. Good job. Now, minus 1 and 1, it's here. Minus 2 and 4. So when it's minus 2, it's 4 here. When it's minus 3, it's 9 here. When it's minus 3, it's 9 here. Now look at the situation that I'm dealing with. I have points from here till here. By no means it is on a straight line. If I just join them with a free hand, no matter how skilled you guys are, if you have these points on the coordinate plane, you will not be able to draw a straight line. That is why when I have an equation like this, I am not calling it a linear equation because it doesn't allow me to draw a straight line. Any equation that you pick up which is not a linear equation or which has a power more than 1, as soon as any of your variable has power more than 1, you will not be able to draw a straight line. Thankfully, it is still a predictable line. If you are dealing with equation like this, you might end up drawing like this. In my dreams, I can call them a straight line, not with my eyes wide open. Okay? So, any equation which is not a straight, which is not having the maximum power as 1 would not draw a straight line for me, and that is why I have not called them linear equation. Let me stop here. What is the question, Advait?
So like the line you draw, was that turned into like calculus?
You guys are in a hurry. Don't do that. Don't do that. Calculus, you can choose to learn calculus in the 11th grade or 12th grade. Okay? Or you can just skip through that if you don't have interest in the subject. So don't rush for it. Right now we are working on the basic foundation of math. Okay? Let's not rush. Okay? But we will see, we started with understanding the coordinate plane, then we learned how to identify different points in the coordinate plane, then we added them with the geometry, say okay, 2 points I can join to make a line, then we saw okay fine, then we have linear equation concept, then we are going beyond the linear equation, say okay fine, if I have an equation, will I always draw a straight line or I would draw different things also. So this is one flavor that we are coming across, and this inverted bucket is called parabola. So when you have a quadratic equation, meaning an equation where x to the power or the variable, maximum power to the variable is 2, you will end up drawing something like this. It is called a parabola. So now let's decode this parabola a little bit more. Is everybody with me so far? Aditya, Sandrine, Sulin, Myra, Sanvita, Smrni, Advik, Arav. Everybody? Okay. Dikshita has been quiet now. What happened, beta? All okay? Gitesh?
Yes,
All clear?
Yes.
Okay. That yes sir has to come loud and clear. As loud as my voice. Okay? That gives me the confidence that yes, my kids are with me. Otherwise, I will just waste your 1 hour and go to sleep. Alright, let's come back. So, we just learned that if I have an equation like this, I will call it a linear equation because when I put a table, x and y value, and plot it in this thing, it gives a straight line for me. That's one thing we learned. Now, what if my power is more than 1? So we'll go slowly. When my power to the variable changes from x to x square, let's say x square plus 1, this is my equation. If I have an equation like this, then, who is it? Who is raising hand? Nobody? Okay. I just tried to be. So when I have an equation like this, when the variable to the x or one of the variable has power more than 1, which is 2, it draws a shape like this. That is called parabola. Okay? So any quadratic equation that you talk about will result into a parabola. Can I take a pause here to assume everybody is with me? Okay. Now, is this the only equation that will give me a parabola? No. Every quadratic equation will give me a parabola. So standard form of a quadratic equation is ax plus by is ax square plus bx plus c. This is the standard form of a quadratic expression. If I convert this into an equation like this is my standard form of a quadratic equation. That means anything, any flavor of this is my standard form. A, B and C are coefficients. A is my coefficient of x squared, B is my coefficient of x, and C is my coefficient of x to the power 0. Okay? And A could be 20, B could be 19, C could be 28, doesn't matter. There could be different possible values. But any flavor of that will only draw a parabola for me. Is that part okay so far? Now, let's look at two different flavors. Okay, so yesterday we did something with the parabola. Let's look at it. Let's talk about y equal to x squared as one equation for parabola and look at what happens if I add a 2. I will quickly do this, okay, so that some of you who have seen it yesterday don't get bored. And then I want to show you guys on one more flavor of it. Who all has done some kind of treasure hunt in life? Do you guys know what is a treasure hunt? When you go on searching for something, when you go on exploring something, when you go on finding something interesting. So we are not learning math, okay? We are doing more of a treasure hunt of the equation, okay? So I would want you guys to just enjoy this experience more with respect to the exploration we are doing, okay? It's nothing to memorize. You guys are still early for being a champ in parabola, okay? We are just exploring and we are just decoding the concepts, okay? Treat it that way. If I ever get you guys stressed out when teaching math, let me know. I would take a break for 1 week, go to Hawaii, do some yoga and come back again, okay? Alright, so coming back to this one. So, these are x and y values for this equation and this equation. Let's say when x is 0 for this one, y is 0, 1, 1, minus 1, 1, minus 2, gives me a 4, 2 gives me a 4, 3 gives me a 9, minus 3 gives me a 9. Okay, so this one is that. This guy, when I do x equal to 0, y gives me 2. When I give x equal to 1, it gives me 1 plus 2, 3. When I give x equal to minus 1, then also it gives me a 3. When I do x equal to 2, it gives me 4 plus 2, 6. When I do x equal to minus 2, it gives me again 6. So, this many points should be enough. Let's plot them here. Let's plot them here. 1, 2, 3, 4. 1, 2, 3, 4. This is on the minus side. This is on the plus side. 2, 4, 6, 8, 9, 10. 2, 4, 6, 8, 10. So I'm going to draw this, okay? So 0, 0, 1, 2. This one I'm doing right now. 1, 1, 2, 4, 3, 9. Advik, it is okay this time? Advik, are you with me?
Yeah.
This time okay, right? Sometimes the teacher is also right. Okay, so this is the parabola I'm drawing for this guy. Now again, don't get stressed out. I have drawn the most horrendous drawing here, okay? Let's just look at the pictorial part of it. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here 3, 6. No, let me not do that. 2, 4, 6, 8. Okay, and there'll be a 10. But anyways, minus 2, minus 4. Now, when x is 0, y is 2. Meaning when x is 0, y is 2. Here. When x is 1, y is 3 here. When x is 2, minus 1, it's 3 here. When 2, it is 6, so it is here. When minus 2, it is 6, again here. When 3, somewhere here. If you just look at these two pictures, what happened? I had y equal to x square here, it is meeting the origin. I had x square plus 2 here. I just added a 2. What happened? It shifted by 2 points. Gitesh, don't scratch your head, you lose hair. Okay, come here. What I'm saying is, if you look at this picture and this picture, what's happening is, when you had y equal to x square, you are starting from the origin of the coordinate plane. When you had x square plus 2, you are starting from this point. You shifted by 2 points above. If you want to play with this, put a minus, you will see that the same thing moves down by 2 points. So this plus or minus here is making your parabola move up or down. Making sense? No? Smarning. Aditya, is it making sense, beta?
Yes, it does.
Yeah? Dikshita, are you in agreement that if I have y equal to x square plus y equal to x square plus 2 or minus 2, it moves up or down by that many points? This is what we saw yesterday also, right?
Yes, sir.
Adri, Karav, do you agree? Maya, is that clear to you?
Yes, sir.
Okay. So we saw one thing. Now let's explore one more part. See, when I said a quadratic equation, I said y equal to x square and then something. So let's come to this one again. So my standard form was ax square plus bx plus c. So this c is nothing but, see, when you look at our equation, right, y equal to x square plus 2, I did not have any term mapping with this guy, so probably b was 0. That's why this was my c. So my c is making my parabola move up or down, depending on whether it's positive or negative. Yeah? Do you guys, are you able to conclude it that way? That whatever is my constant value, y equal to x squared versus y equal to x squared plus 2, this 2, if I compare that with my standard form, is nothing but my c value. Correct? So my c value is the one which is deciding or making the parabola move up or down. Yeah? If I have an equation like y equal to x squared plus 2x minus 7 versus y equal to x squared plus 2x, I will simply assume that if this guy is plotting a parabola like this, then this guy will be the same parabola shifted by 7 points down. Yeah? Ranjan Sulin is also stressed out. Okay, beta? No? Everybody clear, right? Okay. Now, okay. No, I will keep on checking, okay? That's my job. Just to make sure that I am not just moving fast for completing something, okay? I'm okay not to complete fully, but I'm not okay to complete everything without understanding everything, okay? So now, so we have seen one flavor of parabola. Now let's look at this. Y equal to x squared versus y equal to minus x squared. What happens? Adri, do you remember what happens in this case?
Does it like reflect?
No, no place for guesswork. You have to say it reflects or it doesn't reflect. Does it reflect? Maybe it reflects.
It does reflect.
Okay. How about you, Arihan?
Like, instead of it like pointing upward like a bucket, it would be like a bucket upside down.
Okay. Arav, same thing.
Yeah.
Gitesh, same thing.
I think either like a parabola like this or like that, or like it's like shifted down.
Okay. So let's not keep any open questions here. Let's say look at this one. This is my equation. I will just use probably 3 fields. Okay. X equal to 0, it gives me 1. X equal to 1 gives me 1. X equal to 2 gives me 4 for y. X equal to minus 2 gives me 4 for y. Now look at this guy. What is the contract between x and y? X equal to 0 gives me minus 0, same as 0. X equal to 1, x equal to 1 gives me 1 square a minus, so that is minus 1. X equal to 2 gives me 2 square 4, that is minus of that. X equal to minus 2 gives me minus 2 square is 4 and minus of that. Now look at these two scenarios. When I look at this graph, 0 1 0 1 0 0 0 0 0 0 1 1 minus 1 1 2 4. I'm just assuming something, okay? I mean, I'm not putting effort for drawing it. I'm just trying to give you guys some conclusive view. In this case, this is my parabola. Look at this guy. This is my plane. 0 0 starting from here, wonderful. 1 minus 1. So x is 1, y is minus 1. Y is minus 1 in this place. So this became my second point. X equal to 2 minus 4. When x is 2, y becomes minus 4. When x equal to minus 2, here y became minus 4. See? My parabola flipped. All the water I had in this bucket fell down. You did a negative. So you have $50, you did a negative of that. What does it mean? You spent it all. That's what will happen with the bucket. You put a negative to it, all the water will fall down. And how does it fall down? By flipping it upside down. So, jokes apart, simple thing is, this parabola versus this parabola, it is upside down. Now, another interpretation from that is, when your x square is multiplied with any positive value, be it 1, be it 2, be it 9, be it 209, it will be always facing upward. As long as you are dealing with a positive value here, it's facing upward. As soon as you put a negative, this is what happens. So, there are two interpretations that we have drawn so far. Let's look at them. First is, now let's come back to the standard form of the parabola equation. Ax squared plus bx plus c. What we saw was, y equal to x squared gives me a parabola like this. Y equal to minus x squared gives me a parabola like this. Similarly, y equal to x squared gives me, let's say, a parabola like this. When I say y equal to x squared plus 2, my parabola shifts by 2 points here. If I say y equal to x squared minus 2, my this parabola shifts 2 points down. Now you relate with this one. This x squared being positive, see, being positive or negative makes your parabola go up or down. So this is your A thing. If your A is positive, your parabola is facing upward. If your A is negative, your parabola is facing downward. Okay? This is the importance of A. Similarly, in this case, 2. Now when you compare this with the standard form, you don't have an x value. So assume B is 0. In this case, your C helps you move your parabola up or down. It doesn't flip, it just moves up or down. Okay? If you have a parabola equation y equal to 2x squared minus 17x plus 8, if you say, okay, I will add 2x square plus 17x, I will keep everything same, I'll just add this, make it 15, that means you are adding 7 here. So if your parabola was somewhere here, you added 7 to this, meaning it moves by 7 points. Meaning every point of the parabola moves by 7 points upward. Is this part clear? Smarni, Aditya, Myra, Arihan, Gitesh, Sanvita, everybody? Clear? Okay. Now, we have seen these two flavors. What is the importance of A and what is the importance of C? Meaning, if you have a positive value, upward, negative value, downward. Constant value added, keep shifting it upward. If you make it negative, it keeps moving downward. That is this part. And now next thing that I'm going to explore is something new for me also. I have not explored that. What I want to do is this. If I have, let's see how much time we have. We still have 18 minutes. I'll just take a 1 minute break, fill up my water bottle so that I don't get choked. Just give me a minute, just a minute, okay? Okay, so your teacher had disappeared for 30 seconds. Let's look at two situations. If I have y equal to x squared versus x equal to y squared, are these both quadratic equations? Yeah.
Yeah, they are both quadratic equations.
Yeah. They are both quadratic equations because my basic definition of a quadratic equation is it's an equation where the maximum power to one of the variables is 2. One of the variables or both of the variables. Okay. So here in this case the power to x is 2. Here in this case power to y is 2. But maximum power is 2. So I have no regrets for acknowledging both of them as quadratic equations. Everybody agree? Everybody on the same page?
Yes, sir.
Okay. Now, I'm just curious, okay? I have no clue what happens in this case. My only going in position is that this is a contract between x and y. This is also a contract between x and y. I can just identify the relationship between x and y by putting them in table and see what happens. So here, let's go to this one. I will probably pick 4 or 5 points. See how does x and y change. When x is 0, y is 0. When x is 1, y is 1. When x is 2, 2 square is 4. When x is minus 1, it is 1. When x is minus 2, it is again 4. So this is for this guy, okay? Let's look at this guy. What happens? X, y. This time I will put value of y and determine the corresponding value of x. When y is 0, x is 0. When y is 1, x is 1. When y is 2, x is 4. When y is minus 1, then x is 1. When y is minus 2, x is 4. Yes, Arihan.
For the third one, like 4 is x and y is 2.
Yes.
But I thought it was y squared.
No. So see, value of x is equal to y square. So I'm picking up the value of y is 0 and getting the corresponding value of x. When I put y equal to 0, I got value of x equal to 0. When I put in value of y equal to 1 square gives me a 1 here. So x is also 1. When I am putting the value of y equal to 2, x is equal to y square. So 2 square, it gives me a 4.
Oh.
Yeah?
I was like reversing it.
Yeah. No, so see, I'm just curious. I have no idea what I'm landing into, okay? In which direction I'm getting you guys. I'm just on a treasure hunt right now. Okay? Now let's see what happens. So this guy gave me this one. Now let's plot them. This one, 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, minus 2, minus 3, minus 4. 2, 4, 6, 8, 10. Minus 2, minus 4, minus 6, minus 8. Okay. Now let's plot this guy. 0, 0, this point. 1, 1, this point. 2, 4, this point. Minus 1, 1. Minus 1, 1, this point. Minus 2, 4, this point. Okay, this is my parabola, a very familiar one that we have seen so many times. Now let's look at this guy. 0, 0. Okay, this is 1 point. Let me use a blue marker for differentiating this guy. This one, 0, 0. This is a blue, okay? And this is a red. 0, 0. Okay, wonderful. 1, 1. When x is 1, y is 1. Okay, this point is also common, seems like. X is 4. 1, 2, 3, 4. Y is 2. Here. When x equal to minus 1, x equal to 1, y is minus 1. When x equal to 1, y is minus 1. It will be somewhere here, maybe. When x equal to 4, y is minus 2 here. What happened? It rotated by 90 degrees. Yadav, Advik, Arihan.
It's gonna say it rotated.
Yeah, it's rotated. So, remember yesterday when we were talking about it, it's saying, okay, fine. What is the value? What does y equal to ax squared plus bx plus c? This is my standard form. A helps me figure out whether it's upward or downward. C helps me move it up or down. Is it B that is playing a role to flip it? Because my parabola in a coordinate plane could be this way, this way, this way, this way. Right? There are 4 directions I can think of. Even it could be this way also. But net, if I look at at least the 4 corner scenarios, I'm talking about upward, downward, leftward or rightward. In what situation I'm talking about this kind of parabola? Now we are clear. When you are talking about y equal to x squared, it is always upward or downward, meaning the power of y is less, is not squared. That makes my parabola go upward or downward. When my power of x is 1 and power of y is 2, that is when my parabola starts dancing sideways. Is it making sense to everybody? Was this a successful treasure hunt? So, to be honest with you guys, I was not doing any treasure hunt. I was pretending. Because yesterday when we talked, I thought, okay, let me find out an easier way to make you guys believe how it flips. If I would have just picked up that, okay, if you are talking about this, it goes upward or downward. If you are talking about this, it goes sideways. Then that would have been an easy to find answer, but difficult to remember it for long. Now you know that all the drama and circus I did for last 10 minutes, there was a reason to it. Yep. All right. That was the message that I was trying to get you guys. That if you are dealing with parabola, these are some of the very obvious behaviors that you should be able to derive just by looking at the equation, just by having a very high level understanding of it, rather than doing any complex calculation to arrive at it. Okay? We have still just touched the tip of the iceberg. Okay? I mean, there's a lot to learn for parabola, but do we have to learn it tomorrow? No. Whatever you guys have learned so far, that is more than enough. What we will try learning is how do we deal with the basic manipulations of quadratic equations, not with the parabola. Whatever you know so far, that is okay as a jump start for you guys. In the coming classes, we will just spend a little bit of time to understand how do we decode the quadratic equation, how do we play with them, what kind of treasure hunt we want to do, and then we'll keep moving. So one message for you all is that we have just one more month, and that is where we'll randomly pick some topics and we'll try covering that. It could be based on what I choose, or based on if any of you have any special thing that you want to cover ahead of time. That's what we'll do. But then from June beginning onwards, we will start the entire syllabus, this whole churn of 6th to 8th grade one more time. Okay? So that by the time you guys are ready to go to the next year as in the year next to 25, you are all set to get ready for your SAT exam. So this group will start preparing for SAT exam or will be part of the SAT group from 2026 August onwards. Okay? So you guys have one more year. That is what we are doing for completing your the foundation for SAT. Yes, Advik.
Is that for people going into like 9th grade or like everyone?
So again, we'll see depending on who is ready. Okay, I mean mostly it will be for the kids going to the 9th grade in the year 2026. But if any of you, I feel that okay, you have spent enough time and you seem to be ready. Learning is just an exercise. Okay, I mean I would not tag it with a year as such. I will talk to the respective parents. Okay, it's not me taking a decision. It's not me and the kids taking a decision. If I find some of you are ready ahead of time, I'll first talk to your parents, get their consensus, and then we'll plan. Okay, but this is just an information. Yeah, Rav.
Will we still be doing star practices for 6th to 8th grade still?
So star practices, I mean, what do you mean by that? I don't know anything called star practices. I only know concepts. So you have to always tell me there's a concept that is part of the test, and that's what we'll focus on. Otherwise, 6th to 8th grade, all the concepts that we need to learn, we have done one iteration already, and we will start from June is what I was saying. We'll restart again from June is what I was saying. Okay? Yep. All right.
Just out of curiosity, how many what did they talk about on SAT?
If we keep on learning what we have learned so far and we do one more iteration in a more judicious way, trust me, SAT will not look like a surprise to you guys. Okay? Okay? And if you are still curious, there is a place to go. Go to Khan Academy. There are different courses. In Khan Academy, you will find something called Digital SAT Prep. Open that up, you will find 13 units. And that will give you a fair idea of what all are coming your way as part of SAT. But I mean, if I were you, I would not worry about it for now. Let's take it with a pinch of salt. Okay? Alright. With that being said, I will let you guys go. Enjoy the rest of your evening. I'm giving you guys 5 minutes back and giving 5 minutes back to myself as well. And see you guys next Saturday. Before that, I'll upload the video of the class. Give you guys some assignment. Try doing those, not because I'm forcing you guys to. It's more of an opportunity for you guys to check that whatever we have learned, are you able to apply them? Yep. Alright. Everybody okay? No concerns? Not upset with the teacher, right? Nobody? Okay. All right. Enjoy the rest of the evening. We'll see you guys next Saturday.
Bye, sir.
All right. Bye bye. Bye bye. Bye bye. Bye bye.
Bye, sir.
Bye bye. Bye bye.
Sir,
Yep.
I have one question.
What question?
Basically, you know you have three classes, right?
Mm-hmm.
You have the